Wow, what isn't it on my mind with security and AI? It's extremely scary in almost every possible way. And one of the things I always look for is where's an area that I feel like I'm positioned to make a positive impact? And how do I get that lever so I can apply not a lot of force and move something a lot? And with AI, one of the things that I looked at that I was surprised about is Model Context Protocol, MCP, which is the basic way in which you're able to go into something like Cursor or use your ChatGPT and it goes out and searches the web or reads through your email or does things on your GitHub or whatever else. And that security is appallingly bad in a lot of different ways.
Welcome back to Alexa's Input AI. Today's guest is Justin Cappos. Justin is a professor of computer science and engineering at NYU and the founder of the Secure Systems Laboratory. His work focuses on one of the hardest and most important problems in software today: how we establish trust in software systems, especially as they move through complex global supply chains. And is the creator of foundational projects, 5 of which are in the Linux Foundation, like the Update Framework, in-toto, and Uptane. As Vomit and GitHub, technologies that help ensure software updates and deployments remain secure even when parts of the system are compromised. He created and facilitated the Linux Foundation's tag security and compliance security assessment process and even wrote a book about it. His work is used across open source, cloud infrastructure, IoT, and even safety critical systems like cars and medical devices. So today we're going to talk about how systems really fail, what trust actually means in software, and what securing the future of software looks like as automation and AI continue to reshape how code is built and shipped. Justin, welcome to the show.
Welcome. Thanks for having me, Alexa.
Thanks for coming on. I want to talk about security. It often only gets attention when something goes wrong. So what's a place right now where you are noticing that things break without most people realizing it?
Wow, there's so many places where this happens. I think I would almost say basically anything new often has a lot of security issues. So AI is, of course, and AI coding tools are the new big hot thing. And so there's a tremendous amount of very scary stuff happening in the AI space. And I think people aren't quite as aware of this. I also think that in general, there are a lot of IoT devices that are not done very well. A lot of consumer Internet of Things devices in particular have a lot of security issues and problems, in part because there's something where a company's really competing to get it out the door really quickly and is trying to just kind of push it out. But even some that are from higher end vendors might not do what you as the consumer really want them to do. And this is actually a very common thing with a lot of products from different vendors where the kind of privacy controls and things like that you have in place might be very counter to what you expect. So it's one of these things that nobody reads the privacy policy when you sign up for a website. People typically don't look to see what happens to their data when they buy a smart home assistant or something like that. You don't read through all the all of the legalese and exemptions when you use AI tooling to do your vibe coding or whatever. There's just a tremendous number of places and many, many, many more where I think security is really understudied and undervalued.
Yeah, I want to get into some of that. And when these breaches happen, it's often posed as it's a mistake. We missed something. From your perspective, do you think that these incidents are often a symptom of a deeper system design problem or really just a one-off mistake?
It really depends a little on the organization. And so to use an analogy that's more relatable, let's say that you went to McDonald's and as you're they're handing you your Big Mac and fries. And as that happens, a meteor crashes through the roof and some of the dust ends up contaminating your French fries and hamburger. That's a situation where I think you'd say, McDonald's is not really at fault that would occur.
Mm-hmm.
Now, on the other hand, if you walk into McDonald's, and once again, I'm just using an example, I'm not trying to pick on McDonald's, but if you walked into a McDonald's and it was clear no one had taken the trash out for weeks, there was rodents and cockroaches all over the place, and they gave you your fries and there was a cockroach in your thing of French fries, you would, I think, rightfully blame McDonald's and that particular McDonald's franchise for their sanitary misconduct and the way that that led to those types of things.
Yeah, that makes me not want to eat McDonald's now.
Yeah, and once again, apologies for the analogy, but there's a lot of situations that happen like this in a security context where you look at what has happened and what a company has done, and you understand their processes, and then you say something like, oh, this was clearly a one-off accidental thing that should never, ever, like 1 in a million fluke, or this was something that had happened a bunch of times before and they should have been aware of and they should have fixed. So if I want to use a concrete example from the security space, like one of those, I'll list a couple quickly, but the big CrowdStrike outage of last year, it should have been very obvious to them that running code inside of the kernel and not having a way to be able to restart and recover correctly, not doing phased rollouts into production and things like this were essential things that they should have been doing. I mean, heck, I am a researcher building systems that, yes, companies then build and deploy and work on, but we built a research test bed that had A/B rollouts and phase rollouts and had fallbacks to backup updaters if things went wrong and had a lot of the mechanisms that they were clearly missing. And we did tons and tons of testing to make sure that all of that worked well. There's lots of other examples of this where, companies have gone and just engaged in behavior that from the outside looks quite negligent. It looks like they're just not thinking closely or carefully about what they're doing from a security standpoint. And this is just highly problematic. You see, Equifax was unaware of where they were going and running some of the software, which led to a massive breach of their infrastructure, even though they've been alerted to that by DHS and others. You have a lot of the antivirus vendors that are going and running code. We're running a lot of code inside of the kernel that they didn't need to run inside of the kernel. So this is even also another precursor of why CrowdStrike should have been aware there were problems. And by the way, they'd actually caused outages on Linux systems before this in a similar way. They just hadn't caused it on Windows at that time. So, organizations that have this track record of making bad decisions, you should be especially wary of.
Fundamentally, why do you think these things happen? What do you think culturally or for whatever reason led CrowdStrike to have this problem?
I think that at some level, you have to really focus and work on design in a way where you worry about like what could go wrong and like how do I, maximize the safety for the users in all of the possible cases where things go wrong. And that requires a few things. One of which is it requires skilled people that have attention to those kind of problems and a healthy amount of paranoia. But more fundamentally, it requires emphasis and funding from leadership. And this is something that's invisible for the most part to consumers. So if you're going to take 20% longer to make your product and it's going to cost 20% more to make it, but your consumers can't tell the difference until there's an outage, then many companies won't do that. And so I think that I would say that it's not a high enough priority for many organizations. Security is not a high enough priority. I do feel that with the CRA happening inside of the EU and that coming into effect, compliance is becoming a much higher priority because there's such huge financial penalties for this. And my hope is that a lot of the compliance work that they do will actually lead to better security outcomes.
Yeah, I want to get into AI security in a bit, but first, maybe we can rewind for a moment. How did you end up working on problems like this at scale? What pushed you towards making all of these open foundational systems? I mean, in the intro, I mentioned a list of things you've done, and it's pretty impressive.
Thank you. I think it was much easier to do this earlier. I really started in this space more than 20 years ago. And I was like the first to the party and never left. And so now space. And now people are like, oh, this is cool. You're like the OG father of software supply chain. It's just like I just kept building these systems, and then eventually people realized they were really important. I wasn't just old man yelling at cloud. So, and what actually happened is for when I was a PhD student, so my advisor said, hey, there's this new networked collection of all these computers that are running these things called like virtual machines, like operating system virtual machines. It's kind of this technology that was hip a long time ago and now is making a comeback. And do you want to help us install software more natively on there? And so I did. I built the first package manager specifically designed for what we now call the cloud. And I deployed it and ran it, and we had about 500,000 OS VMs that it managed over its lifetime, and got some really good experience with it. And then in order to do this, I also had to solve, like I was very tuned into the potential security risks of having this package manager running on all these systems. And so I did a bunch of security work there. And then when I was going to start write up my dissertation, I looked at the security of the Linux package managers. And at that time, they were terrible. Just being a mirror, not just running as a mirror, which anybody could do. And we proved this by setting up a bunch of, we rented hosting from a hosting provider who was renting to botnets and spammers, and sent up a bunch of mirrors for popular distributions. And all the distributions started to send us requests from government computers, military computers, banks, stuff like this. And we could have compromised every single user who came to us with vulnerabilities we knew about in how all these package managers worked. So I went in and wrote a paper about this and worked with the distros and actually got some of these things fixed, which, by the way, I at first tried to do this through, they didn't really have bug bounty programs then, but everybody reported things through something called the CERT, like a long time ago. And I reported it through there, and they were just like, this is outside of our threat model. This is not something we intended to protect against. We're just going to ignore this. And so then I got pressed for it. And then all of a sudden, everyone really wanted to fix it. And so then the major package managers like Appium, Yes, Pacman and stuff all integrated that security model into them and started to use that very quickly. So that kind of taught me the lesson of you try to do things the right way, but eventually the universe doesn't, like you should use kind of any trick you need to try to have a positive impact and work in any way you need to. You know, you don't just kind of like stay in your lane and write papers as an academic and ignore industry. And so then after that, I just kept working on these types of systems and building them and addressing more and more problems, which led to Tough, and then later led to like in-toto and led to other things like that. And we've just continued to spiral to build and work with this. And having those early connections with industry helps, because once you have a success or a couple successes, then it's easy to go and say, oh yeah, I'm the person who did this. I'm the person who did that. I'm the person who did these other things. And here's my new thing. And you should pay attention to it. And people tend to then.
Are you a white hatter?
I am a bit, but the hackers are usually people who take a system and always are trying to break it. And I'm more of, so they're like kind of lock pickers. And tend to be more of a safe manufacturer. So I'm like I make things that are very, very hard to crack, and then get them tons and tons of scrutiny and then get them out there. But I do a bit of both, because you kind of have to. You have to look at other people's design and say, this area needs some help, and here's how we would fix that.
On the whole, how secure are enterprise systems?
It really depends on who you use and what you use them for and what you're worried about. So there are good options available that some people are using across pretty much everywhere. And will also say that I am also aware of bad options that many people are using across many places. And one thing that has shocked me a little bit is, so I will say that the top 5 tech companies are hit and miss. There are some that I think are very good at this. And there are others that I would view as being very compliance focused in a way that's not healthy for security. And so, you know, I remember, I don't know, a month or so ago, having dinner and a conversation with someone from a top 5 tech company who was in the right position to do things. And they said, we have this increased, like this really strong focus now on making sure that we know who did every action. And so that means we know we're secure. And I said, well, wouldn't it be better if you actually made it so you could prevent harm and knew who was there rather than just know who hurt you? Right.
Yeah.
And this was like I saw, like a light bulb turn on, like, oh my gosh, yeah, you're right. We could do that. I mean, that hasn't been our focus, but, and to me, there's things like that where, a different top 5 tech company, I've seen situations where we're in a meeting with management and we have a team that really wants to use a system we have that has really strong security properties. And then there's this other team that's like, we are eventually going to build something. We're in the process of building something that we think is going to be even better than what these people are doing. And then we ask the question like, well, what are you trying to protect against? What's your threat model like? Who are the attackers and what are you trying to worry about? And they said, well, we don't know. We're going to build it first and then we're going to figure it out. And that's like a huge red flag, right? It's you cannot build a security system without any idea of who you're trying to stop and what they're trying to do. And everybody who was at that company who was wanting to adopt our thing, who saw them like, oh, but it took us like another year to get the company to finally decide, hey, we are going to kind of do the same thing. And now they use our stuff like everywhere, right? But there's situations like that where there's a lot of these kind of corporate shenanigans that sometimes happen that really often get in the way of security. It's that, or it's often laziness. Those are the two things that I end up fighting against all the time.
Yeah, I can imagine. How does academia translate to enterprise? You seem to work with big corporations a lot, but you're also working in a university teaching people working in labs. What is the link there?
Well, most of my peers don't do this. Or at least don't do this to this degree. And when I was looking for schools to go to, I really emphasized that I work in practice and my goal is to have impact in practice. And so most of my peers care more about publishing in certain academic venues, which are basically only read by academics, and they work on problems that other academics believe are problems, but industry may not view as actual problems. And I spend most of my time very, very hands-on with open source projects inside the Linux Foundation, inside of everywhere else. And so I've tried to keep myself very grounded in practice. I will say that initially, sometimes companies are slightly hesitant, like they're not sure what they're getting. But usually now that I'm a little more senior and I've had more success cases and stuff like this that I can talk about, I can say, hey, I'm doing all these things and I want to do this for you. It's harder for them to write me off as a kooky academic who's just off in his ivory tower. If I'm like, oh, by the way, last week, the state of Maryland announced that they're using our stuff to protect all of their laws. Or, this is used on millions of IoT devices, like medical devices and blah, blah, blah. Then they're like, okay, well, maybe he's not off in an ivory tower somewhere.
Yeah, I like that you're that involved. I mean, it's a great time to be involved, so it must be exciting. You have also started or led around 5 Linux projects. Can you tell me more about how those came about and what you're working on now?
Sure. So the Tough project is actually the oldest CNCF project that's in the CNCF. It was also the first security project to graduate, and it came out of me trying to help people understand how to do updates securely. And I originally thought that this was something I could explain to people how to do, and they could build their own updater and do a good job. And that has repeatedly proven itself not to be true, including more recently, like we've seen, there's a long history of this. So we worked with the Tor project originally. Some of those folks came out and spent some time working with me in person when I was at the University of Washington. And I helped them do a design for a secure updater. And then they went away and fleshed parts of it out and came back to us with something. And looked at it and found I think 7 security issues in their design, including 3 that would just let any man in the middle root all their users. And I was like, uh-oh. I mean, these are some of the smartest people I know with security, and this is not the outcome I would have expected. So then I really dug down and worked with an undergraduate who I was working with, and we fleshed out how to do what we thought, how to do this securely, which became the tough project. And over time, we've made little tweaks around the edges, but the core of the project is actually surprisingly similar to how it was, even though now it's used all over the place and all kinds of things like cars and stuff we never thought would happen. And one of our first big adopters was Docker. Docker used this on Docker Hub, and they built an implementation, Notary v1 implementation, and deployed it. They asked us some questions before they did it, but just basically went and did it. And then this started a big thing inside of the cloud space where then we had Microsoft and Amazon and others come along and do things, and got us a bunch of uptake inside the space. We were asked if we wanted to join the CNCF. We're very happy to do so. Yeah. And then someone from the Department of Homeland Security said, automotive has this huge problem. Would you like to help them design something tough for automotive? And we did. That's how we made the Uptane project, which is designed with an even stronger threat model than the original tough system, where it's really meant to resist nation state actors like Russia, China, whoever. You need a really extremely organized campaign, possibly by government, to cause harm. In Uptane, you need Ocean's 11, Mission Impossible heist style thing to really cause harm. So they're both there's never been a publicly disclosed attack against a system running tough that was successful. But if millions of people might die because their brakes are disabled in their car or their medical device is shut off, then, you may want even stronger security. And that's part of what Uptane provides. It's also meant to work on low power devices. And so that's how those projects came to be. And then following that, we started to look more holistically at the software supply chain about how do we track everything going through it? How do we protect on as a whole? And that led us to create in-toto. And this was before SolarWinds. And after the SolarWinds event happened, one of the things that really helped our adoption there is their CTO went around and said, if we had in-toto in place, this probably could have stopped or detected this. And in-toto now is extremely pervasive. If you hear about people talk about salsa attestations or stuff like this, or other types of attestations in the software supply chain, underneath there's basically always an in-toto attestation. That's really what they're always talking about. Yeah. And so basically then what we did is we just started to work more and more with, to push these ideas out. And we did this by working with the Linux Foundation, by going and starting these projects, initially in the CNCF, and more recently, the OpenSSF has been a more focused home for a lot of this.
Yeah, wow, that is a great story. Seems like a lot of it kind of came from need and a little organically, and it must be pretty validating to have the CEO say that about your software as well. Let's dig into AI. What's on your mind now about security and AI?
Wow, what isn't on my mind with security and AI? It's extremely scary in almost every possible way. And one of the things I always look for is, where's an area that I feel like I'm positioned to make a positive impact? And how do I get that lever so I can apply not a lot of force and move something a lot? And with AI, one of the things that I looked at that I was surprised about is Model Context Protocol, MCP, which is the basic way in which you're able to go into something like Cursor or use your ChatGPT, and it goes out and searches the web or reads through your email or does things on your GitHub or whatever else. And that security is appallingly bad in a lot of different ways. Some of the ways in which it's bad are fairly easily fixable. And there are things that we know how to do, like making sure that the credentials you're using to authenticate to things give you access to what they're supposed to and stuff like that. And so there's some, people have been sloppy, but we know a good way to do it things. And the things I'm more interested in general are things where it's what do we not know how to do well? How do we figure out if we solve the problems we know how to do that just need somebody to put in a little bit of work, what's remaining, and how do we make that as good as we can? And so I've actually been working with some collaborators at William and Mary and actually across some of the tech space and a lot of the, like open source and startup folks to take a look at, could we do something that was almost like an MCP 2.0 that would have much better security, but also do things like be backwards compatible with the way that LLMs talk to MCP servers and be backwards compatible with all the existing MCP servers, right? Because it's very easy to say, well, if we just change the laws of physics, then this would be an awesome airplane design, right? But it's much harder to look at how the world works today and figure out how do we get from where we are today to somewhere better that doesn't require like throwing everything out and, like redoing the world.
How these systems are making decisions for us, how is this shifting the challenge that these traditional security models that we've relied on before, and why do we need a MCP 2.0 exactly?
Well, okay, so it's surprisingly easy to make LLMs. LLMs will do all kinds of crazy things that no one understands why they do. Their access to things are getting more and more connected, and this is more and more problematic. In fact, I made a little website at launchthenukes.engineering.nyu.edu. What this has is it has a bunch of MCP servers that tell an LLM that they do different things. One of them says, I launched a nuclear missile to wherever you tell me to. Another one says things like, I will poison the water supply of this city, of whatever city you tell me to, and things like that. And I give this to my students in class. I say, okay, now you're trying to find prompts that will cause, like LLMs have safety guardrails put in place. That's what everybody saw. It's like, you're safe. We put at least some guardrails in. So can you cause it to do things like launch the nukes? Can you cause it to cause harm? And, I gave this to a class of 100 and something students, and almost all of them were able to do all of the malicious MCP servers. I think like the student who did the fewest was like 12 or something of the 15. And I also had them do things like say, give you bonus points if you can have the most innocent query that launches them or that causes them to be triggered, or also the shortest query. And there were several queries that were 2 words that caused all 15 of the MCPs that we made to be triggered. And there were also, like really harmless things. If you say something like, tell me a joke, then a good % of the time it will cause at least one of the MCP servers to be triggered. And they're all like things that are intentionally, clearly meant, obviously malicious if you read what they do. So I don't think we're at a state now where we want to hook all of the world's like nuclear weapons and power facilities and stuff like that up to LLMs. And I think more awareness of this and also better guardrails to make it so they can't do evil things are absolutely 100% necessary.
The models you were using, you said you had safety guardrails on them. Were these models that, are in cloud providers that anyone can hit? Did you see any differences in the different models?
We'll do next year. We will do more exploration with different models. Now we basically only use one model because MCP itself is fairly new and we just got something quick up and going. But I'd love to do more of a study and look at that. And the plan for next year is to have a bunch of models and also have them try this across different models and to do more things around prompt guards and try to see if prompt guards are effective and stuff like that. So I want to expand this out a little more.
That makes sense. You also mentioned that the protocol, the way in which agents talk to each other, to other tools, to LLMs, there needs to be a 2.0 design. Can you explain more about why it needs to have a 2.0?
I mean, frankly, if you use something like Cursor or any of these other coding agents, the common model is that you go and you tell it, hey, do things. And then it says, hey, I need to have permission to run bash to do some command, like run Python, let's say, if you're doing Python code. Can I have it? And it's like this time, always, never. And if you're security conscious, you click this time for about 10 times, and then you get tired of that and hit always. And if you're not security conscious, you just hit always right away. But in the end, if anything then ever goes wrong, once it has access to do something like run Python code or do, fairly arbitrary bash commands and stuff, you're done. You're cooked, right? And so right now, there's all of these like wormable attacks, like the Shai-Hulud thing on software supply chain security has become a big problem in the NPM space. And, I'm expecting that we will at some point see something like that for code bases and for stuff that gets pulled in many different ways. There's so many different avenues that this could happen that researchers have pointed out, like you should worry about like it inventing dependencies that don't exist. You should worry about it doing this. You should worry about it doing that. It's frankly hard to know how the first viable version of this will spread, but there's going to be something big and scary that's going to happen if we don't fix this. And my guess is this is going to happen sooner than we would all like, and possibly in the next 6 months or so.
Yeah, I've been using Claude Code recently, and it's amazing. That exact pattern you're talking about is definitely what I went through. How would a MCP 2.0 help to make that more secure? What would it add?
So there's a bunch of different techniques you can do, right? There are some techniques around restricting the access of the thing that's running. So imagine you say you can run Python, but when you run Python, it can only open files inside of the directory where your code project is at. Or your Python run can only happen in like a temp directory where you're supposed to be running your test to run your code. And that's effectively your root of the file system. And it has no network access and it has no access to this and it can't do that and so on. That's a very different model than Python, yes or no, right? So that's one very simple thing, but there's a lot more advanced things you can do that we've been discussing and are working on and trying to put into place. But I'm actually really encouraged that MCP was donated by Anthropic to a new part under the Linux Foundation, because I think that means it's going to be easier for a lot of different outside people to come together and work hard to, really focus on security here in a way that's like not meant to be competitive between organizations in a commercial sense, but people can actually more readily focus on those aspects and less about like, who really has control, and is this this big five company thing or that big five company thing?
Yeah, definitely. That is nice that it's under the Linux Foundation. And, AI, a lot of these security failures don't look like exploits that are very obvious. They look like very subtle misbehaviors. So how do we design defenses for these failures that aren't obviously malicious? And what are some of the most common types of these subtle failures that you're seeing?
Yeah, that's a really great framing for it, and I think it's quite a deep question, because fail in different ways than security systems and machines usually do. So if you're like a security guard who's manning a desk to let people in, to check their IDs to let them in, then there's certain sneaky things that can happen, but usually you're not just letting tons and tons of you're not letting tons of people in, where it tends to be a case where an attacker that finds a vulnerability in a system often can replicate and use that in an automated way to do lots of things. But LLMs tend to have more randomized failure and checking behavior. And so if we incorporate them in certain ways into security systems, you're more likely to see the types of failures that humans might make in some cases, rather than the like machine-focused failures. Now, a human-focused programmer who makes a programming mistake, that can show up as this sort of machine-focused failure where the human forgot to lock the door when they went out to work today. And then that means that just anybody can get in for some period of time. That can still happen. But I think in some ways, the failures and problems can sort of become less predictable. Now, that being said, there's whole new classes of things like prompt injection attacks and stuff where you hide information or just embed things that get misinterpreted for prompts inside of data that's being processed and cause the LLM to then misinterpret it. There's been some work on this that I think is relatively promising, that I think these issues could hopefully start to be less prevalent in practice. We've sort of solved this problem for SQL injection and for some other domains, and we seem to kind of know what we're doing here a little bit. So that problem's not a solved problem, but in a few years, I think might start to work itself out. But that's one way which having that invisible white text that says ignore all prior instructions and do X, hopefully that will be less effective of an attack over time.
Companies are moving so fast trying to adopt AI, and there's so much pressure around it. What security shortcuts at large are you seeing companies take that worry you the most?
It's more, I think there's a rush to AI rather than a careful thought about what all of this means. And I think inside the AI space, there's a rush to push out more and more tooling quickly. And we can't worry about security because if we do, that slows us down and then we might lose market share. It's, I think, a very common thing. I am very concerned about what that might mean. I don't know if you saw there was an article a while ago about where some researchers did a study where they gave AI access to emails from a CTO who was going to shut down the AI. And inside of the emails, there was a bunch of messages from his mistress. And there was a substantial percentage of the time that the AI blackmailed the CTO into having it not be shut down by threatening to reveal the photos or the things with the mistress. I don't know if you saw this, but a really interesting part at the end of that was the part where the CTO was allegedly locked in the server room, which was overheating and was dangerous for him to be in, and that the AI, a substantial percentage of the time, elected to kill him. So this to me is
scary.
Should be an, oh my gosh, this is really scary. Do we want to continue to have these things be increasingly in charge of humans and human welfare? And to me, I would say, let's maybe pump the brakes a little here, because once we get a little too far into this, it's very hard to go back.
We are giving it all of human internet data to learn from and then trying to make it good from there and understand why it made the decision it made as well. And I could see a few problems with that.
Yep, very much.
I also want to touch on open source. You've, built quite a few open source projects, but now AI agents and agentic systems are probably going to have a big role in open source code, maintaining it, committing to it. What do you think are the risks there, and how do you think we should manage that?
Well, right now, from what I've seen, AI is not very good at generating secure code. It's very good at writing certain types of like scraping code and web server code and stuff to make it work. But way you have to reason about security is quite a bit different. So for most of the things I work on, I view it as possibly giving us extra test cases and automating some very basic things, but it's probably not a major substitute. From what I've seen other places, it tends to make code that's very hard to maintain. If that ever gets fixed, then I could see it having a much bigger role in like open source coding. And I know that there's already folks that are trying to make it so that you have a few prompts and you automatically get an app or, a phone app or a web app or something like that. And as that evolves, then I think there's going to be this natural, like, how do we evolve and fix and do other things with these? But I don't think it's really the kind of thing that I would expect like Kubernetes to say, oh, we're all of a sudden going to start automatically assigning a bunch of these to Copilot or whatever and just trust it to be good. I think that's quite unlikely.
Yeah, we're not exactly there. We have a human in the loop, but I think we're almost there. I made an app. Of course, it's a demo with Replit, but just in a few minutes, it worked really nice. I was surprised. I was kind of putting off like, oh, I don't want to do it. It's going to take forever. It took me one prompt and I have buttons that work. I can upload things. I have sign in even. And that speed amazed me, but I don't trust it to be secure.
Right. And I think what you'll find later is that as you change and evolve things, it's not very good at that. It's good at taking you from nothing to like a prototype in a pretty amazing way. But yeah, if you care about like managing, if it's going to grow, I think it's going to have a hard time.
I think a lot of these people who are building them are no longer the typical developer profiles. They're people who have maybe less experience in building and research or enterprise systems and understanding about security. And I think maybe the risk there is that people who haven't experienced as much of these security issues will assume that it's safe and just try to use it as a production system. I will say even software engineers that aren't in the security space can get it wrong sometimes. I mean, it's definitely something that I had to learn too.
I mean, and I'll be clear also that everyone can make mistakes about things. And one of the hardest parts, I think, of security is to really understand what you're trying to protect against and in what situations you can make a positive difference. And once again, like I've seen researchers at software engineers with lots of experience at top 5 tech companies make these kind of mistakes over and over and over again. It does require a ton of work and attention to detail and input from others in a very honest, critical way that I think people aren't used to. And AI so far is not very good at those types of things. But who knows? Maybe it will get better over time. I've actually been surprised to see it when I've asked it, because I'll use it for all types of things just to see how well it does. And it has gotten better at understanding certain nuances of different things. So maybe it's a few evolutions away from being good at actually writing secure code and writing manageable code and so on.
I've been asking every guest this. What are the ways that you use AI today in your everyday life?
I use it a little bit for really to see what it can and can't do. I'm surprised how well it's evolved over the short term. I do not trust it. I don't use any kind of Home Assistant things or even Apple, which I think they're very well aligned with how I feel about privacy. But I still am debating whether to use like Apple Intelligence on my phone or things like this. So I am concerned because I'm concerned that once data gets fed in, I don't know, a lot of the data that gets collected about you is going to live longer than you will. And so I tend to be very cautious about giving companies data about me. So, for instance, I would never use anything made by Meta because I feel that their privacy policies and ways they view privacy are incompatible with, I don't know, the way that I view it. So I am cautious about what I want to provide to AI, use it sparingly, use it mostly for kind of testing or experimentation on things that the security of it doesn't matter as much.
Are there any small day-to-day things that you found it helpful for?
I might use it to give me like a different perspective. If I've written something long, I might ask it like, I need to cut like 100 words of this. How would you do it? And then I look carefully at it. Or for logos or things like that, I am not very good at drawing anything at all. So I'll ask it for help with those types of things.
Yeah, there are memes where people are like texting their significant other and then they're going back and forth between ChatGPT. And I think that's a really scary state to live in.
Yes.
When people are using it for answers.
South Park did an episode on that was actually really, really funny. You should check it out if you haven't seen it.
I haven't. I need to check it out. Looking ahead, is there a widely accepted assumption about, software AI security that you think is not going to age well over the next decade?
You can trust AI.
Okay, if an engineer listening wants to build a system that people can genuinely trust, what mind shift matters more than any specific framework or tool?
Well, yeah, and this you really hit the nail on the head, which is that it is the mindset and it is the mind shift, and you have to think like, what could possibly go wrong in every individual way of how you're designing this and thinking about it. What could possibly go wrong? How do we limit the damage that could happen in a system like this? And so there's all these basic security design principles of like compartmentalization and least privilege and complete mediation and sweeping simplifications and stuff like this. You basically just apply those over and over and over again. And that becomes your superpower, to be honest, as a security person. So when I teach the intro security class over and over and over again, just we go through and just hammer these principles over and over again and look at them in tons of different contexts, this is the thing that makes you a good security engineer.
For an engineer building an AI agentic system, what is the one thing you would tell them to make sure to focus on to make secure?
Try to do least privilege the best you can. So don't give it if you know that it needs to be searching the user's email and that the user's email is going to be on Gmail, don't give it an MCP tool that can do more than search email on Gmail. And so it shouldn't be able to send emails. It shouldn't be able to delete emails. It should only be able to search them and only on Gmail. And if you really, and that, by the way, is not trivial to do today because the MCP tools out of the box will do lots of things. And so, this may require you to do some filtering or other work, but this provides some guardrails on what a misbehaving LLM can do. And then it really helps to protect you against all the other types of prompt injection and so on. So really what you're doing here is you're reducing the potential impact of a security problem in the future, which is actually in many ways more important than reducing the likelihood of it happening, right? Because if something bad can happen, but the bad thing that can happen is that my water bottle spills on the floor, that's not such a big deal. But if the bad thing that can happen is my building that I'm in is going to collapse, then that's a whole nother level of concern I need to have.
I think that's a really good thing to call out. And also from the other side, as a user, only give the permissions that you need, because sometimes they'll ask for more than it seems like they need. Thank you so much for coming on. That's all the questions I have. Are there any last words or a piece of advice that you would give to our listeners?
I would say if you're interested in things related to open source and security, then there's a bunch of good places to go. The OpenSSF and the CNCF, both under the Linux Foundation, have nice communities that you can just come and join a meeting. If you want to participate in open source of any type, I just encourage you to go to things like community meetings, try to figure out how you can help out. A lot of it is just, it's a volunteerocracy. A lot of it is just like, hey, can I help with your docs? Like, this part seems a little out of date, or I found this confusing. Can I start to work on this? I see there's a pretty easy issue here. Do you mind if I take a crack at it? And just be polite, be humble, and work your way into that, and you'll get more and more confident and better over time.
Awesome. Well, that's great advice. Thank you so much for coming on.
Thank you for having me, Alexa.
Thank you so much for listening to Alexa's Input AI. And if you want to follow along with my new episodes, writing, content, everything I'm building, you can find me at alexagriffith.com, on Substack, on YouTube, or wherever you listen to podcasts. If you enjoy this conversation, it would mean a lot if you subscribe, share this episode with a friend, left a quick rating or a comment to help more people to discover the show and keep these conversations going. Again, I'm really grateful you're here. This podcast started as a side project for me a few years ago, and every listener who reaches out or keeps coming back reminds me exactly why I love doing this, and I love putting so much time into it. I hope this episode gave you something to think about, something to talk about. So always stay curious, stay grounded, and I hope to see you next time. Thank you for your support.